Hey everybody, I just wanted to hop on here and make a quick video of a little mini lesson on adding and subtracting fractions. In our math Google Meet this week, I realized that we struggle with this, so I wanted to just do a little kind of, reteaching of this skill. So go ahead and grab your marker board and a marker, and I want you to work these out with me. We're going to start with, I want to start with addition. Okay, so we're going to start with addition. So I have 4 different addition problems. The first one is 3/5 plus 2/5. Okay, in 3rd grade, we do not ever get into if a different denominator. Anytime that you add or subtract fractions, the denominator is the same. But you still want to always check and make sure, because sometimes on like STAR tests and things like that, they give you addition and subtraction problems that are maybe on a 4th, 5th, or 6th grade level, and that's when they have different denominators. So the first thing you want to do is check and make sure that there are the same denominators. So I'm teaching you adding and subtracting fractions with like denominators. Are the denominators the same? Yes, because remember, denominators is the bottom number, and that's how many parts equal the whole. 5 and 5. So check and check. Okay, next, we look at the numerators. And this is actually the only thing that we're really concerned about. It's the only thing you have to do. So really, it's just 3 plus 2 over 5, because your denominator stays the same. As long as these two are the same, you just go ahead and carry it to your answer. Whoop. Okay. So I have 3 plus 2 over 5. Well, 3 plus 2 is 5. And our denominator stays the same, so 5/5. So 3/5 plus 2/5 equals 5/5, which is the same thing as 1 whole. Let's check that out using our manipulatives just to make sure. So we are doing the problem 3/5 plus 2/5. Let's click on my fraction circle. Here's my fifths, so I have 1/5, 2/5, 3/5. So that's my problem. 3/5 plus I add 2/5. 1, 2. And look, I get 1 whole pizza. I get 5/5. We know that that is correct. Check. All right, next problem. Let's go down here. The first thing you want to check is make sure that you have like denominators, 7 and 7. Okay, if they are like denominators, you can go ahead and carry that denominator to your answer. Okay, to your sum. So now all you have to be concerned with is the numerators. Okay, you're going to just add your numerator like you would. 4 plus 2. 4 plus 2 is 6. Very good. So we know that 2/7 plus 4/7 equals 6/7. Let's try it out. I wonder if they have 7s in this one. There's no 7s, so we're going to pretend there's 8s, okay? So it is 2/7 plus 4/7. So there's 2/7. Okay, so it'd be 1, 2, 3, 4, 5, 6. So 6/7. All right, next one, 6/4 plus 5/4. Now this is an improper fraction. I know this because the numerator is larger than the denominator, but that doesn't change anything whenever we're adding. We just have to make sure our denominators are the same. They are, so we can go ahead and carry it to our answer. 6 plus 5 is 11. 11/4. We can also convert these to mixed numbers. Okay, 6/4. 6/4 actually equals 1 because 4 goes into 6 one time and there's 2 left over. 1 and 2/4 plus 4 goes into 5 one time and there's 1 left over, so 1 and 1/4. You add them together, you'd have 2 wholes because 1 plus 1 is 2 and 3/4. Let's check and see if 11/4 is 2 and 3/4. 4 goes into 11 2 times. 4 times 2 is, because 4 times 2 is 8. 11 minus 8 is 3, so it's 2 and 3/4. 11/4 and 2 and 3/4 are the same thing. Okay, so now let's look at this one. 8/5 plus 1/5. Okay. Actually, I'm going to use my manipulatives for this one. I'm trying to use a very large arrangement of manipulatives and different ways to show you. So 8/5 plus 1/5. Okay, so I've got fifths. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's 8/5, which you know is the same thing as 1 and 3/5. Okay, so 8/5 plus 1/5. Well, all we have to do is just add one more, and that gets us 5, 6, 7, 8, 9/5. We know that we keep the 5 the same, and we just add our numerator. 9/5 is the same thing as 1 and 1, 2, 3, 4/5. So really our answer could be 1 and 4/5 because 1 and 4/5 is the same thing as 9/5. Okay, so now we've done addition. So now let's do some subtraction. 9/10 minus 4/10. The first thing you want to check is to make sure your numerators are the same. 10 and 10, yep, and that means that we get to keep 10 as our answer. Okay, so now we just concern ourselves with the numerators. So 9 minus 4. 9 minus 4 is 5. Very good. So your answer is 5/10. Now, what's another way we could simplify 5/10? How can you simplify 5/10? I know a way. They're both divisible by 5, so I'm going to divide both of them by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. 1/2. Also know that 5/10 is the same thing as 1/2 because 5 is half of 10. Okay, so if I had 9 slices that were broken into tenths, so let's actually do that. Here's my tenths, 9/10. So 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. Okay, and it says I take away 4/10. So 8/10, 7/10, 6/10, 5/10, which is equivalent to 1/2. So I have half a pizza left. All right, now let's look at this one. All right, it says I have 6/6, 2/6, 3/6, 4/6, 5/6, 6/6. Okay. And I take away 3/6. So 6/6 minus 3/6. Well, we know our denominators are the same, so we keep our 6. Now we subtract our numerator, 6 minus 3. I know that 6 minus 3 is 3. So 6/6 minus 3/6 equals 3/6. Let's check it out. Here's 6/6. I'm going to take away 3/6. What am I left with? Very good, 3/6. 3/6 is equivalent to what fraction? Can we simplify this? We can simplify it because 3 and 6 are both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 3/6 is the same thing as 1/2. So again, you're left with half a pizza. Okay, so now let's come over here. We've got 8/4 minus 3/4. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. 8/4 is the same thing as 2 wholes. I know this because 8 divided by 4 is 2. So 8/4 minus 3/4. Let's take away 3/4. What am I left with? 1, 2, 3, 4, 5/4. I also know that I can leave my denominator the same and just do 8 minus 3, and that would get me 5. What is 5/4? It's an improper fraction, but we've got to change that to a mixed number. How can we change 5/4 to a mixed number? Well, 4 goes into 5 one time, so I have 1 whole. Then I have 1/4 left over. And look, I've got 1 and 1/4 because I have 5 slices broken into fourths. So the answer could be 5/4 or 1 and 1/4. All right, we have one more. 3 wholes minus 2/4. Well, if I wanted to go ahead and convert this into an improper fraction instead of working with whole numbers, what improper fraction would be equivalent to another fraction that ends in fourths, that has a denominator that's fourths? So how can I change 3 wholes to an improper fraction to where it still has the denominator of 4? So basically, what number divided by 4 equals 3? Very good. If you said 12 fourths, you're correct. We can change this. 12 over 4. Okay. So 12 fourths minus 2 fourths. Well, we leave our denominator the same. So I put my 4 here. Then I have 12 minus 2. What's 12 minus 2? Very good. It's 10. So now let's convert this. 4 goes into 10 how many times? 2, because 4 times 2 is 8. So I'd put a big 2. Then what's left over? 10 minus 8 is 2. Very good. So I have 2 and 2 fourths. We also know that if you add 3 wholes minus pretty much 1/2, because 2 fourths is the same thing as 1/2, I'd have 2 1/2 left over. Okay, so now let's look at a very similar problem that gave everybody such a fit on Monday and Tuesday. This is a similar problem. I just changed it to you guys. It says Cameron bought 2 1-gallon bottles of milk for her soccer party. Her team drank 4/3 gallon of milk. What fraction of a gallon of juice is left over? Draw a number line to show and explain your answer. Okay, so the numbers we're working with are 2 wholes and 4/3. So how do I know when I go to draw my number line, what numbers do I need to draw? Well, it has to go up to 2. Okay, so I'm going to go ahead and draw my number line. So I'm going to label it 0, 1, 2. Okay, so 2 is as big as it can get because she starts with 2 and we take away 4/3. So essentially, this is pretty much saying 2 minus 4/3. And we can talk about an easier way to do this after we do the number line. Okay, so what do we partition our number line into? Thirds. Very good, because 3 is your denominator, and that's how many pieces equal a whole. So I need to section this into thirds. I'm only putting 2 lines because we count spaces, not lines. So 1, 2, 3, 3 spaces. 1, 2, 3 spaces. So it's broken into thirds. Now I'm going to go ahead and label my number line. So this would be 0/3, 1/3, 2/3, 3/3 or 1 whole, 4/3, 5/3, and 6/3. Okay, so now I need to plot 2 gallons, so 2 wholes and 4/3. So I'm going to go ahead and plot my 2 wholes, and then I'm going to plot my 4/3. And it's wanting to know what the difference is. So what fraction is left over? So we know we're supposed to subtract. So pretty much how many spaces are between 4/3 and 2 wholes? 1, 2. 2 spaces. Now that doesn't mean our answer is 2, because if she started with 2 gallons of milk and then they drank 4/3, how would she have 2 gallons of milk left over? Right. So you know that it has to be 2 fourths, because we skip counted by fourths. This is broken into thirds. So it would be 2/3, 3/3. So 1/3, 2/3, 3/3. So you know that you skip 2 spaces, so that would get you 2/3. An easier way to do this would be just to subtract, like we just worked on. So we have 2 wholes minus 4/3. Well, how can we change 2 wholes into an improper fraction? You have to think, what number divided by 3 gets you 2? Very good. If you said 6, you're correct. So now we're going to make this 6 thirds. You should have also known that answer because we already labeled it on our number line. Minus 4 thirds. So if we did this as improper fraction, we know that our denominators are the same. So we keep it the same for our answer. Now we just subtract our numerator. 6 minus 4 is 2. Say that you don't want to work with improper fractions. You'd rather work with mixed numbers. We can do that too. Erase the improper fraction subtraction problem. Let's change it to mixed numbers. So we knew this was 2. Okay, so 2 wholes minus 4 thirds. Well, how can we change 4 thirds to a mixed number? We can actually use the number line for this. So here's 1 whole, and then we go over 1, so that's actually 1 and 1/3. Okay, so 4 thirds is the same thing as 1 and 1/3. So then you'd skip count to the next one, 1 and 2/3. And this is the same thing as 1 and 3/3 or 2 wholes. So now it's 1 minus 1 and 1/3. Well, 2 minus 1 is 1. Okay. And then you have what left over? You have 2/3. Well, actually, I just totally messed this up. Okay, so you start with your fraction, okay? So I'd take away one of those. So 2 minus 1 is 1. Well, now I'm left with 1 circle of thirds. Okay, so I'm left with 1 whole of thirds. And then it asks us to take away an additional 1/3. So 2 minus 1, I just took away a whole pizza. I'm left with 1 pizza left, but I'm also taking away 1/3. So now I take away 1/3, and that leaves us with 2/3. See, because I started with 2 whole pizzas, and I'm taking away 1 and 1/3. So here I go. I'll take away 1, and I take away 1/3. So that leaves us with 2/3. Okay, so there's 3 different ways that you could solve this problem. You could do subtraction with improper fractions, subtraction with mixed numbers, or you can use the number line and count the spaces in between to see the difference. If you need any help with this, please let me know. I hope you have a fantastic Friday.